welcome back to last session of the day for Data Architecture Day, sponsored by the Triangle Area SQL Server Users Group. Now that I've said that roughly 10 times, I think I got it right this time. So we're going to hand it off to our last speaker of the event, Ginger Grant.
Thank you very much, Kevin, and thank everyone who made it all the way to the last session. So today I'm going to be talking about what is Azure Machine Learning. So Azure Machine Learning has evolved quite a bit. Microsoft has put a lot of effort and energy into it into the past year. And it contains a lot of different components that have been designed to be used not only by somebody who knows what they're doing with machine learning, but also people who don't. So it's designed to be accessible to people who don't know anything about it, and we'll be taking a look at that, looking at the automated portions of that as well. One other thing I wanted to mention, this product has changed a lot over the years. On the downside, it's no longer free. So if you were thinking about the free version, yeah, you can't do that anymore, unfortunately. So, this is the same components of this are included in other tools like Databricks and Synapse. And oh, by the way, you can actually incorporate your Synapse clusters from within Azure Machine Learning. So we'll go ahead and look at that as well. A little bit about me. My name is Ginger Grant. I'm on Twitter at Desert Isle SQL. I have a blog, obviously, at Desert Isle SQL, and I'm also an author of a book and working on another one. I'm a Microsoft MVP and a Microsoft certified trainer. And if you want to get a hold of me, the best way is probably on Twitter. Okay, a little bit about the agenda. We're going to be talking about what Azure Machine Learning does, how you can do stuff like bring your own code to it. We'll be talking about how to do testing and how to do deploying as well. So what is Azure ML? Well, at the 10,000 foot level, what you do with it is you register your data. Well, why that is important is historically with a data scientist creating an algorithm, what they do is they go to a number of different data sources and they refine them and determine what is the appropriate data source for a given task. And after they're done, they say, okay, great, good, we can just run with this. And someone's like, wait a minute, where'd you get all that data? And they're like, oh, it's from here, but I extracted some stuff out of it. And that can take quite a bit of effort and energy to productionalize. So the point with Azure ML is Microsoft looked at some of the common pain points and looked at what it takes to resolve them. So the first step is to register the data. That means when you have to know what you're going to do, you have to say what the data source is that is used with the model. This is just to help with the first step in reusability. Then, of course, you train your model. Now, you don't have to train it necessarily within Azure ML. You can train it somewhere else. Load your model up, do one quick run, and be done with it. Or you can spend all your time in Azure ML choosing to write it that way. It just sort of depends on what you want to do. Then you are going to be evaluating the model. And then deploying the model, of course. Once you've got it done, you want to be able to send it out into the world and take a look at what you can do with it. So what we're going to take a look at first is the individual components that it takes to make that happen. So at the individual components within Azure ML that you work with to use this functionality is first you have the workspace. So a workspace is an environment that is kind of a managed service within Azure. And that managed service contains the different components for managing and monitoring ML. Clusters are the computers that you use to run it on. It seems like everything that Microsoft does is talking about compute being separate, and this is no different. So your compute is separate from the code. So your code is could be in notebooks or wherever you have it, and you can choose how fast you want it to run. Now they've created a UI that you can use with the Azure ML Studio, and that includes a component called the designer. Now the designer is a an environment where you can use a drag and drop interface, and it's very similar to the Studio of old. You can also use notebooks. Notebooks within Azure Machine Learning allow you to write your code or drop in your code from wherever you have it and use that in addition with using your code to use the compute components of Azure Machine Learning. There are also 2 SDKs that you can incorporate. The reason you would want to incorporate these components is to allow you to take advantage of some of the managing and monitoring features of Azure Machine Learning, and these SDKs are available in both R and in Python. So enough talk about this. Let's take a look at Azure Machine Learning. So I need to get to the portal. Okay. So I'm going to, I've got 2 different Azure Machine Learning workspaces here. I'm going to take a look at one of them first and then show you how to create one after, which I realize is a little bit backwards, but I want to make sure that I can show you various components of doing this. Unfortunately, if you want to play around in Azure Machine Learning right now, there's a bit of a constraint when it comes to creating compute resources. So I'm trying to load some of the code that I have up here, but I'm probably going to be going ahead up and creating a new instance for running this. So we'll go ahead and load this and see if I'm able to access my demo here. So this is the workspace, and you'll notice that it says, oh, good, it let me do that. So I've got a compute cluster. So what I can see here is that I can go ahead and open up a Jupyter notebook, and I can use that to access my code. So let's go ahead and sign me in. And then I will have a compute resource that I can use for creating Azure ML. All right, so let's take a look at what it takes to be able to make this work. So what I'm going to do is first off, when I get into Azure, I want to create this environment that we just saw here. So what I'm going to do is I'm going to go to create a resource. And I'm going to create that resource. I'm just going to select AI and machine learning and select machine learning. So a little bit of information about here. Of course, you're going to need to give this a workspace name. So I'm just going to call this new. I'm going to call this new Azure ML. And in my resource group, I want to create a new resource group. And I'm going to call this create new demo AZML. Okay.
As you're building that out, would you mind upping the font size just a little?
No, certainly. Thank you for reminding me of that. How's that?
Looking much better.
No reason. Yes. Sorry about that. I forget because my monitor is only 2 feet away from me instead of, giant screen. All right. So let me go ahead and select West US. And there are 2 different editions for machine learning. You have basic and enterprise. Naturally, with enterprise, you get everything. The question is, okay, so what am I missing out on when I use basic? Well, if you use basic, you cannot use the AutoML function, and you can't use all of the studio portion of the interface. So those are 2 pretty good reasons for going with the enterprise version, which is what I'm going to select here. So I'm going to do that, and I'm going to go ahead and say review and create. So when I do that, I'll have the ability and see if it's creating it now. And it is creating my workspace. Once it is created, then I will have this environment that I showed you here. So let me go back to my Azure portal versus the machine learning resource group. So what I am in now is I am in the UI. So let me go back to the portal here real quick. So from in the Azure portal, when you select Azure Machine Learning, you see several different elements. I'll see if this is done yet. Oh, great. It's underway, which means I'm going to have to be waiting for this one for a little bit. We'll let this one cook, and then I'll go back to the portal, and we can take a look at the different elements within it. So if I'm going to look at my workspace here, what I can see is I can see that I have experiments, pipelines, compute, models, image, and deployments. So if we take a look at this, we can take a look at what I have, or we can look at it from within the studio. Let's take a look at the individual elements from within it. So within experiments, this shows you all of the experiments that I have. Come on. Within the model, and I do not know why it's all blank there. There we go. And this shows me pipelines, which I have several of. This is really weird. And it's, okay, here we go. So now we can see my pipeline. And my pipeline shows you the workflow that I have for Azure Machine Learning, and you can see when it's run and how it's run. So this is actually showing you the list of my models, how many times it's last run, and when it's last been run. So you see all that information from within here, and these are my pipelines. If I click on experiments, I'll just be a little bit more patient, and maybe they'll load now. And this shows all the experiments that I have within my machine learning component. And you can see I've got a number of different experiments that I have created from within here. So, and this is my compute, which shows you the compute that I have available from within this Azure Machine Learning resource here. And it'll go ahead and load these up. And this is telling me that you've got, for many instances, you cannot create compute resources. So if you have a free version, I'm sorry, you won't be able to do anything that I'm showing you at the moment. And then we have the models. These are the components that I'm done with my testing on. So these are ready to be deployed, or ones that have been deployed. And you can see I've got a number of different models listed here. The images, these would be the image of my models that were run. And then deploy, come on. And these are my deployments. And these are the elements that I have created and created so that I can deploy them. So I've got a number of different deployments that I've created as well. And these are the activities showing you the different elements and that I have created within this workspace. So I've got a compute provision, which I just did, experiment runs, and different experiments that I have been running from within my machine learning model. So these are all the different things that I have available to me that I have done within my Azure Machine Learning workspace instance. So when we go to the other way that you can look at the resources that you have contained within here is looking at the Azure Machine Learning Studio. This is what Microsoft is moving to, more of a visual instance available for this. And this is showing you most of the same information, but this is where the visual elements are, including the ability to create pipelines, experiments, and using the designer, as well as automated ML and notebooks. So from within here, we can load different notebooks The one thing that's kind of hinky about the way that notebooks are run is that you have to, you can't directly load them. You have to write a little bit of code to load notebooks into Azure ML, which just seems dumb, but that's just how it works. And you can use the compute that you create, or you even have the ability with code to go ahead and use compute resources that may have been created for Databricks. So you can even use that compute as well. So you're not just limited to this compute. So with a notebook, I could create my code for machine learning anywhere. I can go ahead and make sure that that compute is using this, or I can, in this instance, I'm monitoring my data drift on using Kubernetes. Now, data drift is something that is a big issue with machine learning. With machine learning, what you always need to worry about is whether or not your data is the same as when you tested it. Here's a perfect example. Let's say that you are looking to do some kind of a credit evaluation and you wanted to evaluate somebody's credit back in, say, February. You may have completely different calculations that you might want to use now, given the rampant job loss and that has occurred and the different issues in the economy. So your data that you're evaluating may be different than it was before. So you're going to notice your data has changed from what you tested. And you're going to want to note that and then perhaps retrain your model because your model's was trained on data that had different values. So that's what this particular model is doing, is it's monitoring that drift of data and comparing it to the data that you created, that you used when you were creating this data set. So just some code that can be very helpful with ongoing monitoring for machine learning. So there's a lot of different components in here. It's actually kind of a rich environment. In addition to going to the designer, which you may be familiar with, which shows things like a drag and drop interface that you can use for creating machine learning components. So this is an example of a machine learning drag and drop interface that was created with the designer that's analyzing automobile price data. Now, one thing for all of your compute, what you will need to do is you will need to select where it's going to, where you're going to run it, because your compute is the machine that it's running on, and you always have to assign a machine that it's running on for anything that you have evaluated within machine learning. So we see it's a pretty rich environment, and it's got a number of different components within it. So there's a lot going on that you need to become familiar with if you're starting to use this. All right. So one of the things that I talked about briefly, but I wanted to talk about more about, is automated machine learning. So a lot of times companies employ data scientists to determine what is the best algorithm they could possibly use to evaluate, say, doing some regression analysis. Just for those of you who are unfamiliar, regression analysis is analysis of components to see what the relationship between the different components are. For example, I'm in Arizona and it's hot. And that means that every time that it is this time of year, my electric bill goes up because there is a direct correlation between the temperature outside and the amount of money that I'm paying to the power company. That's one example, but there's a lot of things that are a lot more subtle than that. For example, you may have a group of customers that you have identified as your better customers. They buy more products. And you might want to do an analysis of what elements do my customers who have high profitability have? How are they alike? And that might be some regression analysis that you want to do on your customers. Conversely, you might look at the people who don't pay you, people who are continually late payers. What do they have in common? What do they tend to buy? That kind of stuff is called regression analysis. And that is one of the things that Azure Machine Learning can automatically compute for you. Another component that can be computed within Azure Machine Learning is something like binary or clustered analysis. Clustered analysis is your classic example. Like if you were in an airplane, this is really kind of horrible, but it's kind of analysis that's done. If you are in a plane accident, what's the chances that you will survive the plane accident? A lot of that, by the way, has to do with where you're sitting in the airplane, which is a pretty big indicator of that. And that kind of thing would be what's considered binary analysis or cluster analysis. Those are two of the different kind of analysis types that Azure Machine Learning can compute using automated machine learning. It cannot do every single kind of analysis, but it's really good at doing regression analysis and also forecasting analysis. For example, taking a look at budgets and trying to predict what they will be in the future. Time series analysis is another one's the kind of analysis that Azure Machine Learning can do. So you want to apply automated machine learning when you want to tune a model, and you may not want to spend a whole lot of time trying to figure out what is the best algorithm for the job. So Azure Machine Learning can actually go through a giant list of different algorithms and select the appropriate one. You can see how it is doing that and what is being evaluated, and see how it is training the model and selects the right one. For different common models, there are different ways of measuring the model's performance. For example, if you're talking about binary analysis, you're looking at something that's called a confusion matrix, and you would use that to score which model is the best. If you are looking at regression analysis, there is something called RMAE that has scores, and you would want to pick the best score for analyzing regression analysis. You don't even have to know this because it will do it for you. The service iterates through the algorithms, looks at the feature selections, and produces a score and picks their best one for you. And the higher the score, and the better the model is to fit your data. So you can create this analysis using actual code and not have to know a whole lot about it.
We had a question
Sure.
maybe a couple slides ago. What were the factors in that location decision?
Factors in the location decision for where I choose to load it or create it?
I think so, yeah. It was not on the previous slide, but I think it was right before that.
That was a demo, so.
Yeah, okay, during the demo, yeah.
It must have been during the demo. In terms of where you want to put your Azure Machine Learning cluster, which is what I assume that is, generally speaking, you follow your standard Azure rules. And I wanted to create a machine learning cluster in West US, primarily because that's where my data lives. And so then I don't have to worry about charges from going from data center to data center. If it's not available in every single data center in the world, so it is almost in all the ones in the US, but there's really no major consideration, with the exception of the fact that for some of the compute that you might want to select, if you want to select the most largest compute, that's not available in every single data center, and you select your compute separate from your Azure Machine Learning workspace, but it needs to be in the same server location. Otherwise, you'll incur charges. So if it's important to you to have the most fastest compute possible, then you will need to take a look at which data center you want to put it in for that reason. Otherwise, honestly, it doesn't really matter.
All right, thank you.
You're welcome. But so going back to auto machine learning, this is something that you can use to create code with. So let's take a look at how you do that. So you use automated machine learning to tune it for you. It can do more complex things like tune your hyperparameters. Hyperparameters allow you to tune the model so it is more closely aligned with your data. It allows you to create an early termination policy. When you are running Azure Machine Learning, there is a charge for when you are using compute. And if you get a really good response, there's no reason to go through every single algorithm when you already have a good one. So you can terminate that. You can see how you can select the time for how much time you take to compute how long something takes. So you don't have to take forever in a year if you don't want to pay that kind of money for it, or you can. And then taking a look at your training script and your training data. And those are all of your input. You put that into Azure ML and you get a high quality ML model. One other thing that I wanted to mention is you do not have to do this within the UI, although that's how I'm going to show you how to do that today. Using the Azure SDK in R or Python, you can do the same thing, but within your code and not within Azure Machine Learning. So what you get as an output is you get a recommended configuration with run metrics so that you can say, I know that this is the best one. Now, why would you do this? Because this might be cheaper than employing a data scientist if you're looking at this kind of analysis. And it is selecting a number, going through a number of algorithms that a person would do it, and you get the result quite a bit faster. So it's something that you might want to do just from a cost perspective. Although I will say that from a cost perspective, this isn't the cheapest thing to be doing either. It does take quite a bit of resources to do it, but we're only talking about probably maximum runtime, maybe about, I've done it for as long as 30 minutes. And that's not going to run through over $100. And I know that your average data scientist will definitely charge you that for an hour's worth of their time. So keep that in mind when you're doing it. Of course, your compute will dictate how much you pay for anything. So automated machine learning helps you pick the algorithms and hyperparameters and generates a model. And then you can download the model if you want to customize it further. And this will help you build and deploy ML solutions, and you don't without having the most skilled data scientists on staff to be able to do it. So to automatically train a model, what you want to do is define your settings, attach your training data, modify the settings that control the process, and then submit it for model tuning. After you submit it, it iterates through the machine learning algorithms, hyperparameter settings, looking at your constraints for how long you want it to run. And then it chooses the best fit model by looking at the measures of which makes a good model and running through those. So basically it iterates, what it's doing when it's internally is it takes the information and looking at classification, forecasting, and regression, which is the only three it can do. Looks at the training data. That can be something that you send it to, or you could, if you're writing it in code, you can send it a NumPy array or pandas data frame. You can configure your target compute. You can use Databricks compute if you want to, or use your own resources. Look at the different parameters, models that you want to use. You can select the number that you want to use. And then it runs through all of them, provides scores, and it does this, almost simultaneously, depending upon what you've selected. It can do it exactly simultaneously, and then creates a leaderboard saying, yep, this is the best one. This one's not so good. This is second best, so forth and so on. If you say that go ahead and quit once you've got a score of, say, 95%, it'll do that. It won't keep on running. So you need to look at the important relevant features that are generated when you're doing this. So let's take a look at how you can create an automated machine learning model. And we'll do that by looking here at our automated machine learning element here. So what I'm going to do is I'm going to go ahead and create a new automated ML run. And the first thing that I'm going to want to take a look at is I'm going to want to take a look at using a data set. These are data sets that I've already loaded. I could have these data sets within Azure Blob Storage that I could point to and define that way. And that's what I have done here. So I'm going to go ahead and pick a data set. This is going to be doing some loan analysis. So I'm going to take a look at what the criteria are to make a good underwriting decision based on my data. And this is, my data set is a tabular data set, which means that it's a grid and column data set. You can have a number of different types of data that you can use in this analysis. So I'm going to go ahead and take a look at this. And so it's going to say, what kind of experiment do you want to use? So I could look at an existing experiment that I have, or I'm going to go ahead and create a new one. So I'm going to call this underwriting. And I'm going to take a look at all of my columns. Now these are all the columns that I have. And what I'm going to look at is I want to look at which is the criteria that contains whether or not I want to give this person a loan. So that is, of course, is my loan. So I'm going to select a training cluster. So this is basically saying, hey, what computer are you going to run this on? What computer are you using? And I'm going to use my CPU cluster. I could also choose to create a new compute. And if I did that, I'm basically creating a new machine for this to run on. So I'm going to go ahead and say next. And so here are my types of analysis that I can use. Deep learning is in preview, so that's going to be available soon. So you can do neural network analysis in an automated fashion. So it's going through Keras and I can't remember the other one that it does, that it's preview going through as part of its analysis. So what we're going to do is we're going to be taking a look at classification, because we're going to determine whether or not we're going to write a loan for this person using these criteria. And I'm going to go ahead and say finish. And so it's validating my data, and it's going to start a new run. And my experiment, and we can take a look at my data guardrails here. And I haven't put that, I haven't enabled that. So let's say I just did use the default. So we're going to be looking at the default settings here. And the default settings is basically, I want to look at accuracy. Accuracy is the most important metric for me. And I'm going to take a look at a maximum training time of 3 hours. Or I have a metric score threshold, which I have not set. So I'm going to run this one in 3 hours. And I'm going to do the concurrent iteration is 2. So the max that I'm going to run any analysis is 2, because if I do that, given my existing cluster, it'll start taking too long. So this is my criteria. So this is going to go through and tell me what I am going to end up getting when I do this kind of analysis. What I want to do while it's running, because it might take a little while, is show you what the output of one of these analysis is. So I'm going to be doing that by looking at some analysis that I did in code. So within Azure Machine Learning, if I'm going to look at my compute here, come on. I can show you a model that I wrote in code where I did the same thing that I'm doing here in the automated fashion. So you can see the kinds of things that it goes through. So let me go ahead and click on that. And all right. So one of the things that we can do is taking a look at how I did this within code. So let's see, which one is it? So one of the, let's see, was it here? No. I believe it is, yeah. Taking a look at what it did to do hyperparameter tuning. So here, what I did is I basically had it determine what the best selection was by using its analysis. And I did that by using this Azure ML core. And what this is, it's using the SDK to do my analysis for me. So this is why this is working, because I'm using this particular library. So what I'm going to be doing there is I'm analyzing my data set and then loading my data into pandas, and then basically saying, hey, tell me what the accuracy is, calculate the area under the rock, and then create a pickle file for me. And then what I want to do there is, after that it is running, I want it to go ahead and tell me what's the estimation, tell me how I should do this using this hyperdrive analysis. So basically I'm telling it to compute this for me and then run it and wait for completion. So I can do the same thing that I'm doing within the UI as I can do within code, save the answers, and then I have the ability for it to run. So what it's still doing is going to be running here, and it's going to then create models based on the analysis that I've given it and determine which is the best algorithm that I have, automatically create a model for me, and then I can save it and use it. So I don't really have to know a whole lot about how this works under the covers. Of course, it will tell me the algorithm that it is using when it is complete, and I will have a model that I can then go ahead and deploy. So let's talk a little bit. Hopefully we'll get some results prior to the end of this demo. So one of the benefits of this kind of automated ML is you can take a look at all of the training and hyperparameter, telling it what you want for accuracy, and it'll just generate all that for you. So it automates the exploration processes, helps you use your resources more efficiently. So you can just set this up and run and know that you're going to get the best algorithm part of it. And you can also optimize a model for desired outcome. Sometimes you want, if you're looking at binary analysis, it's not as important to accuracy may not be what the criteria that you're looking for. You may want to look at the F1 score, or making sure that you have the fewest number of false positives possible. Might be a little bit different. And then you can control your resource budget. You can say, look, I don't want this to run forever because that it's not worth it for me. You can take a look at doing it different models and different domains, and then look at the different training frameworks that you want to do and visualize them in one place. So you don't have to have all this pre-set up to be able to make it work. So what you can do with this process is you load up Azure ML, you pre-process your image, you tell it what features are important, you look at a classifier, you save the model, you register the model, and then you can convert it and you can create a Docker image. So of course, once you've got a model tested and created, which is what I'm doing now with the AutoML process, then the next thing you're going to want to do is you are going to want to register the model, create a Docker image, and deploy it. Because the goal is not just to create a model. The goal is to have a model that you can use. Once a model has been created, you can call it anywhere. You could call it from within an ADF process. You've got the inputs and outputs defined. So as long as you have that passed to it, you can run the model from there. You can contain it within a Docker image and load it to a website. So you can actually call it from anywhere. So what you want to do is you want to select your compute instances, because once that is how it's going to be running. And then you can open the sample industries and you can basically look at how you can deploy it. So there's demo code for it. So you don't have to understand everything about how the underlying code works in order to make this work. So the notebook, they'll then display the URL and the port that the service is running, and you just call it from whatever you wish. So you can test that from a local compute instance by looking at the local host and the URL. And from the remote client, you can get a public URL of the service running to see the different compute instance. So there's basically, if you want to look at the samples, it's a great place to do it. So the general workflow is basically you use the SDK to get the connection information, and then you determine a type of request data, and then create an application that calls the web service. So you can, how this does it is it creates a model as a web service using our REST API. And you can send data to this API, receive the data of the prediction that's returned. You can create it by using C#, Go, Java, and Python. And you can create the web service when you deploy to Azure container instances, Kubernetes, or even field programmable gate arrays. You can create images from registered models and scoring, and you can retrieve the URL used to access a web service using the SDK. And if you want to authenticate, you can also use the SDK to do authentication for you. So in closing, we took a look at what Azure does, looking at how you can bring your own code, looking at testing and deploying. One thing I want to show you as well is where you can get some code that will help you better understand how to make this work yourself. And I'm going to go ahead here and go to GitHub. And one thing that is really great is that Azure Machine Learning is the class for that is on GitHub. There is a certification called DP100, and they have made all the information available that you use for studying for that class available for you in GitHub. What this means is that you've got all sorts of information. Oops, here it is. All sorts of information available to you for how to create a workspace and how to do it yourself. So you can actually teach yourself how to create an Azure Machine Learning workspace, all of the code, working with the data, and shows you how to do everything that I talked about within this class. And you can do this just all from GitHub. So it's just kind of a great way. If Microsoft is offering you free tools, then there's no reason not to use them. This is part of the machine learning training resources, but it's under the MIT labs. So you have the ability to take all the time that you want to be able to learn this. But one thing, again, if you are going to be doing this, just know that you can't do this from a free account right now because Azure is resource limited for COVID. So keep that in mind if you want to play around with this, that you do have that constraint when you're creating compute. But definitely, if you're interested in more about it, definitely check out these labs because you can figure out how to run this all yourself. So with that, does anybody have any additional questions?
We will see. There was some discussion mostly around data scientists versus data engineers and the difference in roles there.
Did you enter all of that? Did you get into that large conversation?
It was a fairly large conversation. Yeah, it went on for a little bit.
Well, what was the consensus there? Or was there one?
Essentially, data scientists. So I'm not going to quote my own because, that's just. Data engineers will do most of the pipeline work. Data scientists often have the data set already available, but will sometimes have to do engineering just out of necessity. Engineers building pipelines, getting data available, cleaning, and then scientists following up with feature engineering, summarization of data, helping with analysis, and after that, engineers taking over to productionalize.
I will say that's great if you have that in your environment. A lot of places are kind of too small to have that kind of setup.
True.
So while data engineering is great when you can get it, I will say that I wouldn't count on it being there.
Yeah, no, that's very true. Also ends up being a case where it's like, hey, we hired the very, very expensive data scientist who's now spending all of all of the data scientists' time trying to get a data set out of like some ERP system that is ridiculous. Also, self-service BI. There was a whole bit about self-service BI in here as well. True. So if there
So
are, oh, please go ahead.
go ahead. So I know that Microsoft is trying to do a lot of that within Power BI. I don't know if how well that necessarily works because it doesn't have all of the data components to it. What I like better about what Microsoft did with Azure Machine Learning is that basically what this does, and I didn't really go into it with this presentation, but it allows you to monitor all of your existing models that you happen to have running around. So if you've got like 10 or 11 different models that you've got running, you have no idea if, unless you're monitoring the data drift, like what we looked at briefly, as to whether or not the model is still valid. And I think that that's something that really needs to be automated in any kind of a solution, because people think, I'm done, I'm good now, and wander off. And who knows? I mean, honestly, given the giant, like right now, for example, I would have absolutely zero faith that any model that was created in February would be good now, because things have changed so much. And if you're not doing some kind of automated tool to do data drift, then how can you be sure that what you have is still valid? And that's one thing that this provides a very easy thing to do, and also will notify you if data drift has occurred. Meaning that what you do when that happens is that you periodically run a training test against your model. So you take some of your data and say, okay, I'm going to run some training against this and see if I still get the same results. And if the results then start to vary, you're like, whoa, I'm no longer, 95% sure that this is a good model anymore. So that's definitely something that you want to include in part of a solution, in addition to just, hey, somebody created it and it works now.
Yeah, definitely. There is that whole after the first model is deployed
Yeah.
time. So isn't
And
Synapse supposed to help bridge the gap with BI modeling like Power BI and ML?
so Synapse actually contains a lot of components of Azure ML, and it's funny because they're overlapping. So they're just putting the same code in multiple places. Also, if you look at Synapse, you know that they have a huge portion of ADF in there too.
Yeah.
So what they're doing is they're taking the code bases and putting in places where it makes more sense. They're taking, they're putting the idea of compute clusters that Azure ML has is exactly the same as what you have in Synapse. Everybody's separating out compute from processing and then figuring out how they can optimize that given a certain situation. It's the same as Databricks does. So it's just the way all the cool kids are doing it now.
That is true. All right, let's see if there are any other questions in chat. It looks like that was about it. Anders said hello, by the way.
Oh, hey, Anders.
And also that we're DBA, so we don't have consensus on anything.
There is that. Well, it's funny because somebody asked me recently about ML in SQL Server. And speaking for myself, I just don't see people doing a whole lot of that. Although you can. I think that people are moving away from that whole environment. I mean, yeah, the constraints about only one input, one output was part of it. But I think people would rather just do a pipeline and just put the data they need towards it. What is your experience, Kevin?
So I am one of the few people who does use it pretty actively. And it is simultaneously great and awful depending on your needs. If you can do native scoring, if that works for your models, I absolutely love SQL Server machine learning services. If you can't, but you're okay with batch processing, I'm all right with it. I mean, I know that some people say that the compute is so expensive that you're paying that enterprise licensing, but my thought is I'm not paying it, so I don't really care as much.
Well, I will say that machine learning services is not cheap.
Yeah.
So, as is Databricks, again, not cheap.
Is
So
AutoML? Sorry, go ahead.
go ahead.
Is AutoML like Tangent Works Tim? I know that one.
It's more like Data Robot or what is it? Data something IO data IO, where they basically pick the algorithms for you. So that's a closer analogy. Data Robot has a tool that does it, and Data IO does too.
Yeah, or H2O. There's
H2O,
comment in
excuse me.
chat. H2O is another one, yeah.
So actually, yes, it works a lot like H2O. As a matter of fact, I talked to the product team, and let's just say they were more than a little bit familiar with H2O IO. So yeah,
the competition.
definitely. Yeah, which of course makes sense, right? Why would you not want to look at your competition to make sure that you could be competitive against them?
Yeah.
So yes, H2O IO, it's very similar. Well, one thing that it does though is it tests it out with your. See, the thing is that it does that. Well, I guess H2O IO can, but Microsoft doesn't make any suggestions prior to running it. So it's not going to say, hey, I think that you might want to use these ones, which you can do with H2O IO. It's more like, we'll run through all your data, we'll give you a bunch of results, and then we'll tell you. Which, of course, is an option, but they don't have the other option that H2O IO does. You know what I mean? Where it just gives you some recommendations of things to try.
Right. And another example there was Data Iku.
That one I didn't know. What's that? Data Iku?
Yeah, DATAIKU. I may have heard of them, but it's late for me at this point.
Ah, yes. Well, in my world, it's only, 7 o'clock, so. Not that late. Anything else?
It looks like that's about it.
Great. Well, thank you very much for all your effort that you've gone into with hosting this, Kevin. It's good for you. It's a phenomenal bit of work.
Thank you. It has been a little bit. So, what is the best way for people to contact you?
Probably Twitter. I'm on it way too much at Desert Owl SQL.
All right, excellent. Thank you very much, Ginger. I'm going to switch over to the event closing. And hey, I actually had OBS Studio set up right. So thank you so much, everybody. I see some people who've stuck around for large portions of the day. Definitely appreciate you sticking through it. If you were only here for a little bit, glad you were able to make it. Thank you so much for watching. The videos I would expect to be up by Tuesday. I'll start processing them tomorrow. They'll be on the YouTube playlist that you'll be able to see down below in the description for TriPass. So go check those out afterwards if there's anything that you missed, or if you want to get a quick reminder of some point on there. And with that, next up for us is Shop Talk on Monday. And then the main meeting is on Tuesday. So thanks a lot, everybody, and take care.
Thank you.